Math 3-1, so here's an optional video of the proof of the sum and difference identities of cos and sine at least. Tan, maybe I'll make another video about that one just to show that how tan works. Because once you know these two identities, or these four identities technically, we could just plug them into the tan is equal to sine over cos, and then simplify that down, and hopefully get the tan identity. I'll put that in a different video because it doesn't involve this picture that I'm going to draw here. Okay, so first of all, what I'm going to do to make this picture, to make this true, and this is going to be completely optional. You could just say, no, I don't want to watch this video, and say, I'm just going to take for granted that all these identities, because they're written on the formula sheet, are true. Right? Might as well. So how we're going to do this, I'm going to put myself on the other side here. Maybe too far. Doesn't matter. Okay, I'm going to draw this line on the bottom. Right? Just going to be a flat line. What I'm going to do with this line is I'm going to draw another line connected to the bottom corner. Okay, I'm going to sweep out an angle. Right? So I'm going to start at the bottom here. I'm going to sweep out an angle. I'm going to sweep out an angle of size alpha. Right? I don't know how big that is. It could be as large as you want. I'm just going to draw it right about here. Here's my line. Now, the angle that I just drew, that I swept out, I'm going to label as alpha. Okay. So what I'm also going to do is I am going to draw, insert shape, I'm going to draw another line at the end of that one, and I'm going to continue on. I'm going to continue on, and I'm going to sweep out beta, an angle beta. Right about, let's say right about there. Okay. Angle beta. Okay, and now the only thing that I know for certain is that I'm going to say that the angle beta from this bottom corner all the way up to this part up here, right to the end of that one. I don't care about the ends of these other two, right? But this distance that I have from the very bottom to the very top, I'm going to label that 1. Okay? Now, what I'm going to do here is I'm going to create another line that is perpendicular to the previous line that we drew, and from that top point. So it's going to be 90 degrees here. So this is going to kind of cut that second line that we drew a little bit. And I'm going to save it about there. That looks pretty much 90 degrees. Oops, sorry. Okay. So here, we just made a 90 degrees. Okay? Made that 90 degrees. And there's going to be a new point right here. Okay? Now, to make our lives a little bit easier, what I'm going to do now, based on what we have here, is I'm going to draw a kind of box around this. So I'm going to start here and draw a box around this shape, right about there. And then I'm going to draw another line from here, here. You can continue the box around and make a complete box if you wanted to. I'm not too concerned about that. I just want to know these two sides over here. Okay. What I'm also going to do is I'm going to add in just a little line here. I'm going to add this little line right here. That top dot all the way down to the bottom one. Just because too many lines here, I'm just going to make that a dashed line. Oh, maybe that's not dashed enough, is it? Get a bit longer dash. Yeah, there you go. Yeah, maybe I'll change the color too. Okay, so that line there. And what I'm also going to do is I'm going to add another dash line. We're just adding a bunch of lines here, and you're going to see why I'm going to put these lines there in a second. Okay, you draw another dash line from this dot over to that line that we just drew. There, give that color again. And let's dash it out. There we go. I think that's everything that I need to show the proof of alpha plus beta, sine alpha plus beta, and cos alpha plus beta is equal to those two things that we had before. Okay. So because this is 1, and it could be whatever you want, it doesn't really matter. I just make it 1 just so that it's a little bit easier to do the the math here. But this could be whatever you want it to be, right? I'm just going to make it 1, make it easier, but you could make that an arbitrary length if you want to. If you want to call this G and H or something, that line would be GH. And then you could do everything with the GH as the hypotenuse, and everything will kind of just work itself out. I'm just going to assume that if this is 1, then everything else can also work itself out too. Okay, so now if that is 1, and I got this right angle triangle here, this really, the right angle triangle that's kind of sitting on top. There's a right angle down here too, which might be useful to write. But we got this right angle triangle on the top here. And if I go sine beta, sine would be opposite, so that'd be going over here, over the hypotenuse, which is 1. So this line over here, from H down to, I don't know, let's call that I. Okay? H down to I, that line is sine beta. Okay? Hopefully you can agree that this line here, from here all the way down to here, that's sine beta. Now from the G here all the way down to I, the bottom part of that triangle, that's going to be cos beta. Hopefully you can agree that as well. The same logic, right? Cos is going to be adjacent over hypotenuse. And then just rearrange for the adjacent. So you can do that. Go cos beta is equal to adjacent, which I don't know, over the hypotenuse, 1. Times the 1 up. The question mark that we have there is going to be cos beta. Cool. A few other things I can get from this idea is that alpha at the bottom here. Now, this is where it's going to get a little bit tricky because alpha's hypotenuse, the triangle for alpha, its hypotenuse is not 1, it's cos beta. So if I want to do like sine alpha, that's me trying to find this question mark over here, because that would be the opposite side. It would be the question mark over the hypotenuse, which would be cos beta. So that question mark, the first question mark we're going to draw there, if I just rearrange this, it's going to be sine alpha cos beta. That looks familiar. So this is going to be sine alpha cos beta. Okay? Oh, sorry, I'm going to have to. Yeah, I'm not going to bother giving the PDF of this anyway. If I do for the bottom one now, let's get rid of that question mark. Let's put the question mark down on the bottom from here all the way down to the very end. That's going to be cos alpha is equal to question mark over cos beta. So that bottom question mark, this one here, is going to be cos alpha times cos beta. Okay, looking pretty good. So we got some key pieces there, pretty good there. So that's going to be the whole distance across the bottom, from here all the way down to here. So that's going to be useful to know that that's that whole distance. This one here is just going to be this from here to here. Okay. Using some other logic, that's going to help us in the bottom there. So we know parts of this kind of rectangle that we have here. But what I want to know, the other parts of this rectangle, I want to know how large these pieces are from here to here and from here down to there. If I know those pieces, then I can find out the sum and difference identities, or at least the sum identities of these angles. So what we're going to do here is use a little bit of logic. If this is alpha down here, therefore this angle right here is also alpha. I'm not going to show the proof behind that, but that's just opposite interior angles. And this is 90 degrees. That's alpha here. This will also be 90 degrees here. And then I can find out what this angle is here. And then I can use that to find this angle, which ends up being alpha as well. Okay? So I know that this angle up here is alpha. Okay, we could show that with that 90-degree triangle there if you wanted to later on. So now using the same logic I did down here with this alpha, Yep. Without alpha, I can do the same thing. I can say, okay, sine. Yep, because there's a 90-degree triangle right here. So this here would be sine. So this distance down here, that would be sine right there. So sine alpha is equal to question mark over my hypotenuse, which would be sine beta. So this little piece down here would be sine alpha sine beta. Okay. Then I'm going to do the same thing with the cos. I'm going to go cos alpha is equal to question mark over sine beta. Rearrange that, and I'm going to get this piece here. Cos alpha sine beta. That's going to be this distance from here to there. Just to there, not all the way down to that line there. Now, because this is a rectangle, this piece here is going to be the same as this piece over here. So that's going to be cos alpha sine beta. Okay? And then this bottom piece is going to be the same as this one up here. It's going to be sine alpha sine beta. Okay. So I can just put that line. And let me just write this down. So it's not my way. Okay. So now what we can do here is think about the bigger picture. Now, what if I add alpha and beta together? If I add alpha and beta together, I'm going to get this larger triangle right here. So that angle, this total angle right here, that's going to be alpha plus beta. There's a hypotenuse of 1. So if I go sine alpha plus beta, it's going to be question mark over 1. Okay? Now, the question mark can be related to a bunch of pieces on this triangle, right? Sine is from the very top to the very bottom. So that's the sine. And you can see that there's two parts to that. There's this piece up to this dot here, and then there's this piece up to the top as well. So those two added together should give me that really big line. And those two pieces added together are sine alpha cos beta plus, and I think if I go up there, it should say cos alpha, yeah. Cos alpha sine beta. And there we go. Looking pretty good. So that is one of our identities, right? If you look at your formula sheet, sine alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta. Awesome. Then the other one is going to be, what if I did cos alpha plus beta? I have a question mark over 1 again, right? Now that's going to be this bottom piece. Let me put it in green this time. That's going to be this piece all the way to here instead. Okay. So you could see that that's going to be this whole length minus whatever this piece here is, this little question mark here. I'm going to go right to the very top to do that. You can actually stop halfway and say, that's sine alpha, sine beta. You can go right to the top, sine alpha, sine beta. So these distances are all the same. So it's going to be the full distance minus that little piece. There's the other one, right? It's cos minus sine. Okay. Now the other identities, they come from different identities or two other identities that we have. What we can do is we replace some of the identities in here, right? Now, one identity that we haven't talked about before, is based on kind of the CAST law, the CAST rule, add sugar to coffee. If I have a negative angle in cos, that's just cos. It's just the same thing. Just because where cos and the cosine quadrant and the all quadrant are, they're just on opposite sides there. So if I have a negative beta, it's the same as a positive beta because it'd be on the same side of that. And I can also say another one would be sine negative beta is equal to negative sine beta. Right? So I can use these two here, where I can just switch the signs of beta, or alpha minus beta or cos minus beta. I could switch the signs of all the betas, which will switch the signs of some of the sines and the coses. And then you get your two other identities. I'll leave that for an exercise there, so you could do that substitution for you. Notice I didn't do it for the alphas because you don't have to change the alphas. The alphas are positive in both these. It's just the betas that change their signs. Okay. Now, once you know these two, you can just go sine divided by cos and get tan. Right? It gets a little bit more tricky because it's kind of ugly, kind of looking tan thing. It does work out. Right? If you want to make it tan, right? Which is tan alpha plus tan betas over 1 minus tan alpha tan beta. Right? So you can use those two to create these two, to create the tan ratios as well. Okay, I'm not going to show that. I could leave that for an exercise for you as well. But this is just the introduction to how did we get these ratios. Now, from now on, you can just take it for granted that they are true. Or should I say that at the very beginning of the video? You could just stop the video and just said, okay, I trust that they work. They're on the formula sheet, so why would they be otherwise? All right. So I will see you in the next video. Bye.